Prior to the implementation of the PGBCR, the median student retention rate in 12 sections of the course taught over a 4-year period was 75%, ranging between 47 and 87%. After the implementation of the PGBCR, student retention increased to a median of 85%, with a range of 78 to 86%. This is a dramatic improvement to previous retention and well above the Lone Star system-wide retention rates. Student survey data indicates a twofold increase in the number of students planning to continue in geology. This graph is showing data for all sections of the course taught between the fall of 2005 and the summer of 2009. In blue is the percent of students that scored 85% or higher on the first 2 exams. The first 2 exams are a lecture test and a lab test. So we use this information as kind of a rough estimate of the capability of each class. And if you look at the fall of 2006, you can see even in 2 sections taught in the exact same semester, there's a variation in the capability of the individual classes. In red is shown the final grade mean, and this would be the mean of all the students who completed the course. And the retention percent is shown in green. And again, we calculate a retention percent based on the number of students who started the course and the number of students who completed the final exam. The start date for the implementation of PGBCR is the fall of 2008. So all the sections taught between the fall of 2008 and the summer of 2009 were taught with the complete template. And prior to the fall of 2008, the template was not available, although components of the template were available, such as the web quests. If you look at the retention data prior to the fall of 2008, you can see that there is a dramatic fluctuation in retention rates, even within individual semesters between 2 different sections of the course. Post the implementation of PGBCR, you can see that the retention rates are relatively consistent and mostly above 80% for all sections, as well as a relatively consistent final grade mean. One aspect of this research that is not shown by this graph is that prior to the implementation of the PGBCR, there's basically the classes were breaking out into 2 groups of students. One group of students that was doing well throughout the semester, and another group of students that kind of progressively fell further and further behind as the semester progressed. And towards the end of the semester, these students would just start disappearing because they weren't doing well. What I noticed after the implementation of the PGBCR was that these students that weren't doing well were actually hanging in there, and I was able to close the gap between the students that were doing well and the students that I was losing previously. So these were the students that brought up the retention rate within the class. I also will say that the enthusiasm for the course material increased in both the students that were doing well and the students that were doing average to subpar work. A Blackboard gives us the capability to track the amount of time students spend at the course web page or the PGBCR. And during the fall of 2008, these are pretty typical tracking results. During the fall of 2008, we tracked 48 students in 2 sections of the course. The total time the students spent online was 2,751 hours during the 13 weeks of the semester. That averaged to 57 hours per student per semester, or 4 hours per student per week. 7 students spent over 100 hours, averaging 7 hours per week, and 1 student spent over 200 hours, averaging 14 hours per week at the course webpage, in addition to attending every lecture. This graph is showing data from 2 sections of the class taught during 1 semester, and the data is presented by individual students. In blue is the final grade of the individual student on a scale of 0 to 100, and as red is the total time that spent in hours that student spent online at the PGBCR. As you can see, that there isn't a direct one-to-one correlation between the amount of time spent online and the final grade in the class, but there is obviously a trend that the students that spent more time online tend to be the students with the higher grades. If you look closely, you'll notice that there are several students that did well in the class, that didn't spend very much time online. It could have been that these students were going online, printing the material out, completing the work offline, and then logging back in to submit their work. And I did not survey the students to determine if that's what they were doing. It could also be that they were getting their information from the textbook and from the lectures and were not really interested in the online material, whereas the other students were more interested in exploring the links and the additional information provided online. As I mentioned earlier, 90% of the students taking this course are non-majors fulfilling a general education requirement. With the implementation of PGBCR, there was a dramatic increase in the number of students inquiring about continuing in geology, whether it was to complete a geology major or a geology minor. There were other students that were interested in taking at least one more geology course, whether it be environmental geology, oceanography, or historical geology, which are the 3 other courses offered at our campus. This is a critical impact because unlike other scientists, biology, physics, and chemistry, most geology majors take their first geology class in college. This is where they discover geology. So in summary, the implementation of PGBCR resulted in an improvement in student retention by at least 10%, more than double the number of students interested in continuing in geology. We think our approach can be utilized as a model for other geoscientists and STEM disciplines, and potentially as a model for improving our K through 12 STEM education. Well, we feel like we've just begun. The future plans for this project include designing and building an Angel learning system physical geology course template. We are putting a team together of geology instructors throughout the Lone Star College system to build a template for this course that would be made available to the 25 instructors teaching 85 sections of this course annually. We also are putting in place plans to design templates for the introductory chemistry and biology classes. These are both high-impact STEM disciplines.